Okay, so this is section 8.5, square roots. So square root is basically the opposite of squaring something, and the definition is on page 780 if you want to look it up, but it just means the opposite of squaring something. So an example of that, the square root of 144 is 12, because if we take 12 and square it, or 12 times 12, we get 144. So then if I do the opposite, square root 144, I would get 12. Okay, that sign that we use for that, it's kind of like a division sign, but it's got like a little kicked out a little bit more here. We call that a radical sign, and your square root goes underneath that. Now, we have two different things. We have a positive square root and a negative square root. Positive square root would just be, we're taking the square root of something like 36, and we're going to get the positive version of the answer. We could also have a little negative out front, which means when we take the square root, they want the negative version of the answer. And both of these answers actually multiply to 36, because if you think about it, 6 times 6 is 36, but also a negative 6 times a negative 6, since negative times a negative is positive, that also comes out to be 36. Okay, so that's why we can have two different options there. Okay, so what we can do here is, they say simplify each expression. So if we have square root of 100, we're basically just looking for a number times itself that gives us 100. Well, in this case, 10, if we take 10 times itself, so 10 times 10, we get 100, right? So our square root of 100 would be 10. Okay? Same thing with the next one here. If we've got negative square root of 81, well, what number times itself gives us 81? Well, that would be 9. So 9, and then since there's a negative out front, we just put a negative with our 9. Okay. Next thing here is radical expression. So it's an expression containing a square root. So basically, just kind of a problem. So like maybe it's like 5 plus square root of 25 or something like that, where it's a problem or an expression, but they also throw a square root into it. Okay, next two things here, prime number and composite number. So those go together. Prime number, you can look it up in your book, but basically what it means is its only factors are 1 in itself. And what factors mean is they're numbers that multiply to be another number. So like 2 is a prime number because the only things that multiply to be 2 are 1 and 2. Same thing with 3. So 3 is a prime number because the only things that multiply to be 3 are 1 and 3. Okay, so I'm going to list out some prime numbers here. So we've got 2, 3, 5, 7, 11, 13, 17, and then they would just keep going from there. Okay, 2 is the only even prime number because every other even number like 4, 6, 8, those can all be divided by 2. But 2, the only way to divide by 2 is 2 and 1, so that's why it's the only even number that's prime. So our composite numbers are basically all the numbers that aren't prime numbers. So our composites would be like in between 2, 3, and 5. Well, then we've got 4, and then 6, and then we keep going from there, 8. 9 is an odd number, but it's composite because if we take 3 times 3, we get 9. So you can have odd composite numbers, 10, 12, 14, 15, 16, and so on. Okay. Okay, next thing is prime factorization. So basically what that is we are taking a number and breaking it into a bunch of prime numbers that multiply together to be whatever the original number was. Okay, how we do this is we take our number here, so like 225, and we break it up into things that would multiply to be that number. So if you think about, okay, 225, well that ends in a 25, so if I think about quarters, I could probably break that into 25s because it ends in 25, so if I think about quarters, how many quarters would it take me to get to 225 cents? Well, 25 cents for my quarters, that would take me 9 quarters to get there, okay? Because 4 would get me 100, another 4 would get me 200, and then to get to 225, I'd need one more, so that would be 9. So then what I do is I break those even further. So then I want to take 25 and see what 25 can break into. Well, I know 5 times 5 gives me 25. So I'm going to go 5 and 5. And then 9, I know if I take 3 times 3, I can get 9. Okay? So now the goal of that was to get that down to prime numbers. So if we look here, 5, 5, 3, and 3 are all prime numbers, so we've done our prime factorization. Now what we can do here to check that we did this right is we can take 5 times 5 times 3 times 3, and that should give you 225. Okay, so that would be prime factorization, is breaking a number into all its prime factors or a bunch of prime numbers that multiply to be the number that we started with. Okay. Next thing we have here is the product property of square roots. So they are basically saying if we have a square root, we can break it into a multiplication problem. So if we change 36 into 4 times 9, well, 4 times 9 is 36, right? So we haven't really changed anything. We just kind of changed what numbers are in there, but the value is still the same. Then what this property shows is that if it's in the square roots like that, we can actually break it into 2 separate square roots, and then just do square root of 4, which we know to be 2, square root of 9, which we know to be 3, and then if we take 2 times 3, we get 6. And if you think about it originally, square root of 36 is also 6. Okay? Now this might not seem like a big deal for small numbers, but once we get to bigger numbers, it's a lot easier to do it like this than to sit there and guess and check with bigger numbers. Okay? Okay. So next thing here, we've got square root of 256. So what we want to do here is we want to try to pull out perfect squares from this. Okay, so if you don't have a list of your perfect squares, might not be a bad idea to write them. So we could go, first perfect square is 4, well actually 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, what's after that? That'd be 12, 169, 196, and then that's all I remember off the top of my head. So what we can do here, so basically 1 is coming from 1 squared, which is 1 times 1. 4 is coming from 2 squared, 2 times 2, 3 squared, and so on. If you wanted to write all those in, you could. It goes all the way up to 14 because that's as high as I can remember off the top of my head. But those will kind of be helpful for us. So what we want to do is we want to take those numbers, those perfect squares, and see if they are factors of 256. So what I would do is I would start with, usually I don't start with 1 because everything has a factor of 1, so I just kind of skip the 1 and start with 4. So what I would want to do is I would want to take 256 and see if it's divisible by 4. Okay, well it is. So if I take 256 I get and divide by 4, I get 64. Then what I want to do is I want to see if 64 is on my list, which it is. 64 is 8 squared. Okay, so then what I can do here, since I have 2 perfect squares that multiply to be 256, is I take 256 as a square root and I split it into square root of one of my numbers, which was 4, and square root of my other number, which was 64, because I know square root of 256 is equal to 4 times 64. Okay, so I'm just breaking it into the 2 perfect squares it is. Because now, based on my information here, I know that the square root of 4 is 2, and I know the square root of 64 is 8. So then what I can do is I can just take those 2 numbers, so 2 times 8, and get my answer of 16. Okay, now if I was going to check that on my calculator, second square root of 256, I should get 16, which I do. Okay. So then the next one here, we want to do the same thing. So we've got 900, so we want to take square root of 900 and break it into some perfect squares. So first one we can check is 4. So if I do 900 divided by 4, I get 225. Well, if I look on my list, it doesn't go up that high. So then maybe I want to try something else. So maybe I try 9. So if I do 900 divided by 9, I get 100. Well, 100 is on my list because 100 is the perfect square for 10 times 10. So what I would do here is I would take square root of 900, break it into square root of 9 times the square root of 100, because 9 times 100 gives me 900, and you could write it out that way too. So 9 times 100 gives you that. Then we can break it into what the square root of 9 actually is, which is 3. Square root of 100 is 10. So then I take those two last numbers after I do that and I multiply them. So 3 times 10 gives me 30. Okay, and if I did the square root of 900 on my calculator, so second square root 900, I would get 30. Okay. Okay, so on page 356, try out E through F on your own. When you do these, make sure you're going through these steps and showing your work, because when you take the test on this stuff, you won't be able to just plug it in your calculator and go, okay, square root of 900 is 30. You're going to have to show me this work here to prove that you know how to do this. Okay, so when you do E through F, make sure you show your work, and I will get you the answers here. So E, after you solve it out and do your stuff, should be 104, oops. That's the problem. It should be 12. And then for F, it should be 18. So for 12, or for 144, I'd maybe break it into, what would it be, 16 and 9. I think 16 and 9 multiplied would be 144. So maybe you could try that. And then 18, 4 and 81 would be probably what I would go with there for your numbers to break it into, because those are both perfect squares. Okay, next one here, quotient property of square roots. So the one before was multiplying for product. Now we've got quotient, which is divide. So they're basically saying if we've got a big square root like that of 4 nines, we can break it into square root of 4 over the square root of 9 and then solve those out separately. So like here, if we've got negative square root of 100 over 9, I can break that into negative square root of 100 over square root of 9. And then I know square root of 100 is 10, so that would be negative 10 over, and square root of 9 is 3. And then I could just leave it as negative 10 over 3. Okay. And the next one here, do the same thing. So I can take big square root of 81 over 121, break that into square root of 81 over square root of 121. So that would be square root of 81 is 9 over square root of 121 is 11. So that would be 9/11ths. Okay, and you can just use your chart for that, because that'll help you with a lot of those perfect squares, that chart that we wrote down before with all the list of perfect squares. Okay, so the next thing is try some on your own. So G through H on 359 you can try, and then I'll get you the answers here. So for G, they got 8/9, and for H, they got 3, and they got 3 because it would have been 6 over 2, so if you got 6 over 2, that just reduces down to 3. Okay, and then the last example here says the formula R equals 0.56 times square root of A gives the approximate radius R of a circle that has the area of A square units. Find the radius if the, I'm sure that's supposed to be if, so find the radius if the area is 15 square centimeters. Okay, so I know my area is 15, so I know A is equal to 15, and my goal is to find the radius, the R. So if I take the 15 and plug it in there, so R is equal to 0.56, oops, that's kind of a 6. So 0.56 times the square root of, well, instead of the A, I'm going to put the 15. Now, if I look back my chart, 15 doesn't come out nicely when we do a square root, but they just want an approximation here. So I would just use my calculator if they ask for an approximation, and I would just do 0.56 times second square root of 15, and then enter. And we're just going to get an approximation here. It's not going to be exact. The exact answer would actually be this with the square root in it. But since they just want an approximation, because they say approximate, we can just write our radius is, and then if you do like a squiggly equal sign, that means approximately equal to. And then we'll just go 2 point, and I don't think they tell us what to round to. So we'll just go 2.17. That should be good. And we were measuring in centimeters. So we'll go with that. Okay, so that's all for that. So your book page is page 360, 16 to 44 even. Make sure when you're solving these out, if they're bigger than 144, so if you have to do something bigger than square root of 144, so like maybe you had square roots of 900 because we had that one before, make sure you show your work on ones bigger than that. If they're smaller than that, like square root of 36, you can just use your chart because I know you probably know that one off the top of your head. But if it's a bigger number there, make sure you're showing your work so I know that you actually know how to do it.